My dear students, Assalamu alaikum. So today we will start a new chapter which is called the condensation reactions, and this chapter has two parts. First one is base catalyzed condensation reactions and second part will be the acid catalyzed condensation reaction. So now we will start the base catalyzed condensation reactions. So first of all we want to know that what are the active methylene compounds. So active methylene compounds are those compounds, for example, we have this compound. So any carbon or methylene which is attached to electron withdrawing group, that methylene is called active methylene compound. Okay. For example, why we call it active methylene compounds? Because when we treat this one with a base will remove a proton from this carbon, CH2 carbanion. Now this carbanion is stabilized. Why? Because this negative charge is resonance stabilized. So due to this reason, it is very easy to remove proton from this methylene. So due to this reason, this methylene is called active methylene compounds. So all those methylene carbons which are attached to any one electron withdrawing group, they are called active methylene compounds because they are very active, and any base can remove proton from these methylenes, because after removing proton a carbene ion is formed and that carbene ion is resonance stabilized. So it is very easy to remove proton from these methylene compounds. So this is the reason these are called active methylene compounds. For example, if you have another compound and you want to remove proton by removing base from here, from this carbon, CH2. Now this is not possible. Why? Because when you remove proton from this carbon methylene, this carbene ion is produced. This carbene ion is not resonance stabilized. Due to this reason, it is difficult, it is impossible to remove proton from this methylene. However, if you want to remove proton from this carbene which is attached to the carbonyl electron withdrawing group, it is very easy. Why? Because after removing proton, this carbene ion is formed which is resonance stabilized. So in this compound, this carbon is active methylene. So it means all those methylene carbons which are attached to any electron withdrawing groups, they are called active methylene compounds. Okay. So the donating groups that can withdrawing groups that activate methylene compounds, they are different one. For example, nitro group is the most strongest withdrawing group which activate when it is attached to any methylene, that methylene will be activated. Then COR carbonyl groups, then cyanide group, and then any carboxylic group. All these groups, when attached to any methylene, the methylene are converted into an active methylene compounds. Okay. Now any one methylene to attach this group, that methylene is activated, and it is very easy to remove proton from that methylene groups. Now second one, if an methylene group is attached to two electron withdrawing groups, what happens? For example, in this case, this is called malonic ester. And we have another compound of this type, acetoacetic ester. So these are the examples of two compounds in which the active methylene compound, this one and this one, is activated with two electron withdrawing groups. This one is very strongly activated, so very weak base can remove proton from these methylene groups. So these methylene groups are activated with two withdrawing groups in malonic ester and acetoacetic ester. So it is very easy to remove the proton from these two types of compounds. Now, in active methylene compounds, when you remove the proton by using a base, minus H will be removed. So this active methylene compounds has contributing structures. So it means that the negative charge also comes, oxygen also comes to carbon. So due to this reason, these compounds are called enolates. Why? Because it has an ene and ol function, so these compounds are also called enolates. Active methylene compounds are also called enolates. Next one. The enolates have two types of functions. Enolates carry out two types of functions. When enolate is formed, for example from this one, and you remove the proton, these are the reversible reactions. So now these enolates can carry out two types of functions. For example, when you treat with any carbonyl group, they will react and make a bond. And second, when you treat them, this active methylene compound after moving proton, when you treat this one with any alkyl halide, this will make a bond. This will attack on this one, halogen will be removed. So you can see that in both reactions there is always a formation of carbon-carbon bond. So this is the reason why active methylene compounds are so important, because these active methylene compounds are always used to form the carbon-carbon bond. These are very important in organic chemistry because carbon-carbon bond is formed with the help of these active methylene compounds, with the help of these enolates. So this is an important method for the formation of carbon-carbon bond in organic chemistry, and these are mostly used for the formation of carbon-carbon bond. And we have some bases which can be used. Most important bases that are used are hydroxyl, ethoxide, ethanol, and so on. These are the bases that normally we use for the base catalyzed condensation reactions. And one base I want to mention is lithium diisopropyl amide. It has like this one structure. And this is an active charge, this is a positive charge. This is called LDA, lithium diisopropyl amide. We can show it like this one, Me twice, CH twice, and positive. Sorry. So lithium diisopropyl is a special type of base. Why? Because due to its big structure, it cannot be used as a nucleophile. It cannot attach, so it is only used for abstracting a proton. So when you use this one, this cannot be used as a nucleophile. It only removes or abstracts a proton from active methylene compound, and reaction will start. So when you want to make a carbon-carbon bond, these active methylene compounds are used with this any other basis. So what are some other points in active methylene compounds? Now as we can see that we have contributing structure in which we have a negative charge also on oxygen. So this oxygen can also be used to make a bond like this one. When the negative charge comes on this, then this can react with aldehyde group like this one to make a bond. But this type of bond is very weak. Why? Because in this case carbon-oxygen carbon bond is formed, which is very less important, less stronger as compared to the C double bond C. So always that this carbon will make bond and oxygen will not make a bond at all. So always the reactions will take place with this carbon making a bond. So oxygen carbon bond will not be formed, will not take place.